Now that we have an idea of what a solution to a system is, let's take a look at a couple of examples of how we could have 0, 1, or infinitely many solutions. So we'll only look at the 2 variable and 3 variable case because realistically, a lot of real world problems are going to have 4 or more variables. And the problem with that is that we need an axis for every single variable. So when you plot in 2 dimensions, you need 2 axes, x and a y, or a horizontal and a vertical. When you're in 3 dimensions, you need 3 axes, and that's already the space that we live in. If you think about it, we live in a 3-dimensional world. So the 4th dimension is really not something that we can very easily visualize. There are techniques for it, but there's no sense in trying to do that because, again, a lot of our problems will be in much higher dimensions, what we call n-dimensional space. So in the 2 variable case, we can have 0, 1, or infinitely many solutions. Again, as long as we're dealing with systems of linear equations. If they're nonlinear, then that means functions can bend, curve, and come back and intersect twice, let's say. But with lines, it's not possible, right? So 2 lines could have 0 solutions if they never touch. And the only way that they will never touch is if they are parallel and have different vertical intercepts, right? This one has a vertical intercept of 10. This one actually has a vertical intercept of up here somewhere, and of maybe about 20. So these lines will never touch, and therefore they have 0 solutions. Then there is the most common case that we've seen before, which is that we have 1 solution. That means there's 1 point that they share in common. And infinitely many the only way that could happen is for the 2 lines to be the same. And hopefully we can see here there's the blue line and there's this red dotted line. And this has infinitely many solutions. And then notice they are the same line. So they are collinear, they share all of the same points. Now in 3-dimensional space, the visualizations get a little bit more dynamic and we have to think about it a little bit more deeply. There's lots of ways this could happen, by the way, in 3 dimensions to have 0 solutions. It's not just the case that 2 of our, remember they're called planes, the idea is that if you take a bunch of lines and glue them together, infinitely many of them, you get what's called a plane. It looks like a sheet of paper, a flat sheet of paper. And one way that could happen is, notice here you have the green plane and you have this red plane, right? And if you can kind of visualize this, here's this plane and it comes down like so. And it slices through this blue plane, and so does this red one. But notice that the red and the green planes are parallel, and therefore these 2 planes will never touch one another, even though they touch the blue plane. Remember, it has to be a point or points where they all share in common. And since there's no point that all 3 blue, green, and red planes share in common, this would have 0 solutions. Also take a look at this in an application and show you, visually we can kind of scroll around and see. Now in this case, if you notice we have the green plane, we have kind of this brownish red plane, we have the blue plane, and they actually do intersect in 1 point, and it appears it's right about there, right down there somewhere. Do that in a different color. Okay, that's the point of intersection. This would have 1 solution. What that solution is, we don't know, we don't care at this moment. I just want you to get the sense of how this works. Now in this case, notice we only have 2 planes. We have the blue plane, we have kind of this dark red brownish plane. And if you notice, if you take 2 sheets of paper, you kind of like slice one into the other at any angle, there's actually going to be a whole continuum of points that they share in common. In fact, look at this purple line that I'm drawing here. This is every brown, we'll just call it a dark red plane intersects the blue plane. And actually the reason you're seeing kind of a lighter values down here is because we are actually below, we're in negative z territory, so that's cutting through what we call the xy plane. And so, yes, there are infinitely many solutions, they actually intersect along an entire line. So that has infinitely many solutions. And is this the only way you can have infinitely many solutions, is to have 2 planes in 3 dimensions? Absolutely not. We could actually have another plane that maybe slices through going this way, and it's kind of difficult to draw, but imagine that plane also slices through that same continuum of points, and therefore you could have infinitely many solutions take place that way. Again, 4 dimensions, harder to visualize, but I wanted you to have a sense of some ways in which this could happen in 3D. In 2D, there's really only these 3 cases of how this could happen, although you could technically have a 3rd line in 2 dimensions, and maybe that 3rd line shares no points in common with the other two lines, and that could also lead to no solution.